let's take a look at an example of a tangent function. So let's do y equal to the tangent of negative pi times x minus 4. Now, first of all, the negative pi has already been factored out, so we're okay with that. However, we can't have this value here for b be a negative value, so we're going to have to use, kind of combining step number 1, step number 2 together. We're going to have to use the odd property of the tangent function to rewrite this. So if you remember, since tangent is an odd function, we know that tangent of negative x actually equals the negative of the tangent of x. That's the definition of what it means to be an odd function. So if I use that so that I can make the value for b positive, I can rewrite this as y equal to the negative tangent of pi times x minus 4. And again, I was using the odd property of the tangent function to get it to look in that form. So now I have my value for b positive. So now my value for b is pi, which is greater than 0. All right, third thing here. We need that value for a. So in this case, our value for a is negative 1. So that tells me two things. First of all, it tells me that I'm going to have a reflection, since a is negative. I'm going to have a reflection across my center line. And also, I'm going to be 1 unit above and below my center line. So I get those two things. My value for a is negative 1, so that tells me we have a reflection across my center line, and then we're 1 unit above and below. Now, there is no plus or minus out on the end out there, so my value for d is 0, so that immediately tells me that my center line is going to be the x-axis. All right, so fifth thing here, we're going to use all this stuff inside here, inside the tangent function, to help us find the new period. Now remember that when we originally graph the tangent function, we graph it from negative pi over 2 being strictly less than, in this case, we have pi times x minus pi over 4, so pi times x minus 4, and that being strictly less than pi over 2. You normally graph tangent, you graph it from negative pi over 2 to positive pi over 2. So first thing is I'm going to divide everything I see here through by pi. So I'm going to divide by pi, I'm going to divide by pi, I'm going to divide by pi. So that's basically just going to divide my pi out everywhere. So I'm going to divide everything through by pi. This becomes negative 1/2 is less than x, which is less than 1/2. Dividing everything through by pi. Sorry, x minus 4. Without the minus 4. Sorry about that. So now if we add 4 everywhere, so we add 4. Now 4 is, I need the common denominator. 4 is the same thing as 8/2. So I'm going to add, just getting the common denominator here, so I'm going to add 8/2 everywhere. So when I do that, this becomes 7/2 is less than x, which is less than 9/2. So I'm going to use that to get the new period for my function. So my new period here is going to be 9 over 2 minus 7 over 2, and that's going to give me 2 over 2, which is going to be 1. So the new period of my function is 1. The original period for tangent is pi, but basically when we put that pi in there, we had to divide that out. So my new period now for my function is 1. So here's my first quarter point is going to be at 7 over 2, and there's my last quarter point going to be at 9 over 2. All right, to get my increments here. Sixth thing here, you get my increments. I'm going to take my period, and I'm going to take 1/4 of that. So 1 times 1/4 is going to give me 1/4. So I'm going to start at my first quarter point, which is 7/2. And then for my second quarter point, I'm going to take 7/2, and I'm going to add 1/4 to that. So we've got to get a common denominator of 4. So that's going to stay as 1/4. I multiply top and bottom by 2, so that's going to become 14/4. So 14/4 and 1/4 is going to give me 15/4. So for my third quarter point, I'm going to do the same thing. I'm going to take my previous quarter point, which is 15/4. I'm going to add a fourth to that. So 15/4 plus a fourth, that's going to give me 16/4, which is 4. And then my fourth quarter point, since I need to get a common denominator anyway, I'm going to leave it as 16/4. And I'm going to add a fourth, and that's going to give me 17/4. And then my last quarter point, I should end up at 9/2, so just make sure you end up at 9/2. So take 17/4, and you add a fourth to that. That's going to be 18/4, which is going to be 9/2. Again, just double checking to make sure. All right, so now we're going to use all of our quarter points. We're going to use our reflection, and we're going to use how many units we are above and below the center line to draw us a sketch of our graph here. So this is tangent, so remember, since this is a tangent function, remember that it has asymptotes. So our first quarter point was 7/2, last quarter point was 9/2. So we're out over here, I'm just going to arbitrarily put 7/2 on here. So 7/2, got an asymptote there at 7/2, and then counting by fourths, we get our quarter point. So my second quarter point was at 15/4, and then my third quarter point was at 4, or 16/4, which we reduced to 4, and then my next quarter point was at 17/4, and then my last quarter point was at 9/2. And again, that's where my other asymptote is at 9/2. Now normally, with the tangent function, it is an increasing function. However, because we had that reflection across our center line, and again, remember our center line is the x-axis, and we're 1 unit above and below that center line. So I'm 1 unit above that center line, I'm 1 unit below that center line. So I'm at 1 and -1. So normally, this would be an increasing function. So at 15/4, it normally would be at -1, but we had that reflection, so now at 15/4, we're going to be here at +1. My value there for 4 stays right there on my center line. And then my value for 17/4 is now down here at -1. And then just draw you a sketch of what the tangent function looks like with the reflection. And with the reflection, the tangent function looks a lot like -x⁻³. You got your picture there. But again, I have to see all the x and y axis labeled and then a sketch of what the graph looks like. So hopefully my example that I gave you for sine and my example I gave you for tangent will guide you when you're doing variations of that. So sine and cosine are very directly related, and tangent and cotangent as well are very directly related.